Vaishnavi, how are you?
Good, ma'am.
What happened, Vaishnavi? I didn't see you yesterday.
Ma'am, I went out of town, ma'am. My uncle died, so I need to be.
So I have uploaded the PPT, yesterday's PPT. So the second part of electrolysis, you will have to manage on your own then. Okay.
Yes, ma'am.
So we are going to start with the revision now. 1, 2, 3, 4, 5 are already there. So last week also 2 classes I had to cancel because you all were having exams and it wasn't possible to conduct a class. So my screen sharing is disabled. So children, today we are going to do a revision in electrochemistry. We have completed the topic and now I think maybe sometime next week you might be having a test. So this is the revision. If you have any questions, please post it on your website and I will answer those. Now anyway, we are going to do the revision. So I have first kept all the formulae together, the formulae of my camera is also misbehaving. So first I put all the formulae together. So I started with the part that we started yesterday, Faraday's first law, that is W is equal to Z into I into T. And W, if I simplify, I taught this yesterday. So instead of Z, you may sometime have to, if value of Z, which is the electrochemical equivalent, is not given to you, you may have to use this formula. So we did the derivation. Those who are not present can see that yesterday's PPT. Then Faraday's law, second law, W1 by W2 is equal to E1 by E2. Then this is the equation which is used for calculating the cell potential of a standard cell. Then this is the equation where you calculate delta G of a cell. And then the next one is the Nernst equation in case the conditions are not standard conditions. Then the next few formulae are related to conductance of a cell. So R is equal to, that is resistance, and connecting resistance to cell constant, and connecting specific conductance to or conductivity to cell constant. And here this where I have written L, it is actually I couldn't type it correctly. It is actually lambda. So here it is lambda. Here I hope you have understood it is lambda. Okay, and here also a lambda instead of L, it is lambda. In some places I was able to correct it. This is also lambda. Okay, so these are the formulae. I hope you understand them. Then molar conductance can be converted to equivalent conductance. This part anyway, I've written the formula, but this is not, I don't see any questions in CBSE for it. Kohlrausch's law and then degree of dissociation. Okay, then this is how you write the cell notation. So all the formulae that we have used, we have. Now we'll do first, we'll start with a few MCQs. So all of you who know the answer, I want all of you to participate and answer the questions. Okay. Please note down the answers. Anyway, you will get the PPT, so you will be able to do this. See it again. But right now, tell me. First one, the cell which converts electrical energy into chemical energy is called. Who will answer this question? Cell which converts electrical energy to chemical energy. Somebody? Hariharan. What is the answer? Have you read the question? The cell which converts electrical energy to chemical energy. It is known as what cell?
Is it electrolytic cell, ma'am?
Huh? Yes, electrolytic cell. And what is the first one? The first one is a galvanic cell. So electrolytic cell is, this is the correct answer. The electrolytic cell converts electrical energy into chemical energy. Galvanic cell converts chemical energy to electrical energy. Okay, chemical to electrical. Okay. Then this is the unit of ohm inverse and meter inverse. You can write meter inverse or centimeter inverse. So ohm inverse and centimeter inverse is the unit of, who will tell me this answer? Hari Raghav? Hari Raghav? See, all those who have, tell me the answer. Hari Raghav? Answer is, read out the answer to me. What do you think? Ohm inverse and centimeter in meter or centimeter inverse is the unit of?
Is it option A?
No, that is molar conductivity. So if it is molar conductivity, then some moles will come, no, in the answer. So the answer here is specific conductivity. Right? In molar conductivity, moles will come in the answer. In equivalent conductivity, equivalents will come in the answer. Right? So it is molar conductivity. This is a unit of specific conductivity. Now, resistance of a solution is 150 ohms and the cell constant is so much. So the conductivity of the solution is how much? Can you tell me? Who will find out this answer? Sanjay, can you tell me? See, all those children who have no internet issues, Please, for God's sake, I request you to switch on your camera. Please. So, Sanjay?
Ma'am, 2 into 10 to the power minus 5.
2 into 10 to the power minus 5. Very good. Excellent. Which formula did you use? Conductivity, kappa is equal to what? Resistance 1 by R into cell constant. Right? 1 by R into cell constant. So, K is equal to 1 by R, resistance is given 1 by 250 into 0.005. So that comes to 2 into 10 raised to minus 5 ohm per centimeter. Okay, very good. Then for next question. For 1 molar solution of acetic acid, molar conductance is this much. If molar conductance molar conductance for this concentration is this much. If molar conductance at infinite dilution is 390, its degree of dissociation. How will you find degree of dissociation? Alpha is equal to molar conductance divided by molar conductance at infinite dilution. So can you find the answer? Who will tell me the answer?
Option C, miss.
Option C, very good. So it is 0.02. Those who are able to, if you have any difficulty, please don't hesitate. All right, so it is 0.02, very good. Now, what is the EMF of a cell corresponding to the cell reaction? This is the cell reaction. And E0 for zinc and for iron is given there. Reduction potential for zinc and iron is given there. What is the cell potential? This is easy one. Who will answer? Who can answer? Hariharan. Vishal, can you try this one? I can give you a hint. E cell is equal to E0 cell is equal to E0 cathode minus E0 anode. Okay. So how will I find which is the cathode and which is the anode in this cell? Anyone, please, all of you please don't keep mum like this. Vaishnavi, tell me. Vaishnavi?
Ma'am, I'm solving.
So where is the oxidation taking place? Where does oxidation take place? Oxidation takes place at the, I have told you, and lone, remember, left oxidation, anode negative. So oxidation takes place where? At anode. I've also told you anox and red cat. Right? So oxidation is always at anode and reduction is always at cathode. So here what is happening? Zinc is getting oxidized. See, the oxidation number is increasing and iron is getting reduced, right? So since zinc is getting oxidized, zinc should be the anode and iron should be the cathode. So how will I write E cathode minus E anode? So what will that be? Minus 0.41 minus.
Ma'am, is it option D?
Yes, answer is option D. Very good. Plus 0.76. So it will become plus 0.35 volt. Now in the same way, Vishal, now did you understand how do we find out what is undergoing reduction and what is undergoing oxidation? Now this time, the cell notation is given to you. So you know this side is the left side is the anode and the right side is the cathode. So can you tell me what will be the E cell for this? Cathode and anode reduction potentials are given to you. So what will be E cell, Vishal? E0 cell will be equal to reduction potential of cathode minus the reduction potential of anode. Reduction potentials are given to you. So Vishal, are you there with me?
Yes, ma'am.
So tell me, what is the reduction potential of cathode? What is the cathode here? Copper, right? So what is the reduction potential of cathode? It is given there, isn't it? Plus 0.34. And what is that of the anode? That is zinc,
Second
right?
option.
Yes,
0.76.
0.76. So answer is 1.10
B, ma'am.
volts. B, answer is B. Okay, now let's take the next question. During electrolysis of alumina, now Vaishnavi, you should pay attention because you missed the class yesterday. So during the electrolysis of molten alumina, 13.5 grams of aluminium are deposited in 1 hour. What is the charge passed in Faradays? How much charge is passed in Faradays? So what did we learn? Can somebody answer? Sai Kalyan, can you tell me? See, yeah. Yes, Sai Kalyan.
Measure
Somebody
using
answered.
Faraday's first law we should do.
No, it is 13.5 grams only. That you should remember. What is the atomic mass of aluminium given here? 27. So 3 Faradays deposit how many? 27 grams of aluminium, right? 27 grams of aluminium is deposited by 3 Faradays. Okay, you can write it the other way. 1.5, right? Very good. Answer is 1.5. Who answered, Sanjay?
Yes.
Okay, 1.5. Very good. Now, when zinc granule is dipped in copper sulfate solution, all of you should be able to answer this. When zinc granules is dipped in copper sulfate solution, copper is precipitated. Why? Because both copper and zinc have positive reduction potential. Reduction potential of copper is higher than that of zinc. Reduction potential of zinc is higher than that of zinc. And both copper and zinc have negative reduction potential. Here I made a mistake. It should be copper. Reduction potential of zinc is higher than that of copper. And both copper and zinc have negative reduction potential. So why is copper precipitated? Yeah, somebody tell me.
Ma'am, is it C?
Reduction potential of zinc is higher. Actually, I will write the reduction potential of both. Zinc is E0 Zn2 plus 2Zn, right? It is minus 0.76 volts. And for copper, E0 Cu2 plus 2Cu, reduction potential is equal to plus 0.34 volts. So can you tell me now? B, it cannot be the option. The option is reduction potential of copper is higher than that of zinc. So whichever has a higher reduction potential will get reduced more easily. So when zinc granule is put in copper sulfate solution, what is the reaction that is happening? It is Zn plus Cu2 plus. It will give you Zn2 plus Cu. Copper is getting precipitated, right? So why is that happening? Because zinc, the reduction potential, which is getting reduced. Copper is getting reduced, right? Why is copper getting reduced? Because the reduction potential of copper is higher than that of zinc. Whichever has higher reduction potential will get reduced. So answer is B. unit for molar conductance is? Who will tell me? Ninth one.
Option D, miss.
Actually, it is ohm inverse, no? For conductivity, ohm is inverse. So answer is
Option
A.
B.
A. Answer is A. Right? Can you remember the formula? It is molar
Option A.
conductance is equal to kappa into 1000 divided by molarity. Right? So what is the unit for molarity? Moles per centimeter cube. What is the unit for conductivity? Conductivity is kappa is equal to 1 by R into L by A. So R is ohm. So 1 by ohm into length centimeter by centimeter square. Right? So what is the unit for kappa? It is ohm minus 1 and centimeter minus 1. That is for conductance. Conductivity, specific conductance. All right. Now, if I put that here, what is the unit of this one? Ohm minus 1, centimeter minus 1, divided by moles upon centimeter cube. Right? So what will the unit become? Ohm minus 1, centimeter square when it goes up, and mole minus 1. Right? This is the unit. So answer is A. Ohm minus 1, centimeter square, mole minus 1. These units are very, very important. You should understand the formula and then arrive at the unit. The number of Faradays required to reduce 1 mole of Cu2 plus to metallic copper. Now, those who were present in the class yesterday should answer this.
Ma'am, two.
Two. Answer is 2. Very good. Answer is 2. Now let's take the next question. Which of the following
Ma'am, for a
decreases
second,
with?
can you go to the before slide, ma'am? Thank you, ma'am.
Now, which of the following decreases with dilution? Okay, which of the following decreases with dilution? So I told you conductance increases with dilution, right? Whether it is strong electrolyte or weak electrolyte, conductance always increases with dilution. In case of strong electrolyte, the freedom of ions is there when it becomes a dilute solution. In case of weak electrolyte, more ions are formed on dilution. So conductance, molar conductance, equivalent conductance, all increase with dilution. The only one which does not increase with dilution is specific conductance. Why? Because what is specific conductance? It is the conductance of all ions present in 1 centimeter cube of the electrolyte. So if I make the solution dilute, the number of ions in 1 centimeter cube of the electrolyte will reduce, and so specific conductance will reduce. Okay, so that is. Then which of the following solutions has least specific conductance? Specific conductance directly depends on the dilution. More dilute solution means lesser. It's directly proportional. So more dilute means less specific conductance. So who will tell me the answer of the 12th one? Madhavan, I don't know whether he is attended. Huh? What is the answer of the 12th? Answer is D, right? Which is the most dilute 0.002. Okay. 13th one, resistance of 1 molar solution of acetic acid is 250 when measured in a cell having cell constant of 1.15 per centimeter. Equivalent conductance of the solution. This also I should correct, not equivalent, molar conductance of the solution. What is the molar conductance of the solution? Okay, here per mole minus 1. Everywhere it will be mole minus 1. Mole minus 1. Here also mole minus 1. Tell me. So resistance is given. Cell constant is given. So conductance, molar conductance. So first what will you find? You will find kappa. What is kappa equal to? 1 by R into cell constant.
The answer 4.6.
Huh?
The answer 4.6.
Yes, answer is 4.6. Correct. Perfect. Okay, so this is cell constant. So you can find it is equal to 1 by 250 into 1.15, right? And then divide that whole thing by the molarity of the solution, that is 1. Okay, so it is 1.15 divided by 250. It is 1.15. Cell constant is 4.6 is the correct answer. Let me just check. I think it is correct. So 1.15 divided by 250. Into 1000. Okay. Now specific conductivity of here it is, you make it N. M. Specific conductivity of 0.1 molar KCl solution is given. The resistance of the solution is 100 ohm. So what is the cell constant?
1.29.
1.29. Correct. Perfect. Who gave me this answer? Sanjay, you gave?
Yes.
So where are the others? All answers are being given by Sanjay only. All others are understanding. Please tell me. Hari Haran. Yeah. Hari Raghav has disappeared again. Okay. Okay. Now the next question. Yeah. Now next question is for Sai Kalyan. Tell me. If F represents Faraday and N is the Avogadro's number, then the charge on the electron is equal to how much?
Is it option C?
It is option no. N is the Avogadro's number and F is Faraday. What is 1 Faraday? Sai Kalyan, are you reading and working out this question? Are you there, Sai Kalyan?
Yes, miss.
Tell me, 15th question. Are you able to, can you answer the 15th question?
I'm doing it.
Okay. What is 1 Faraday? Sanjay, what is 1 Faraday? 1 Faraday is
Ma'am, it's the
equal,
answer F by N.
yeah, answer is F by N. Okay, Faraday is what? Charge on 6.02 into 10 raised to 23 electrons, right? Or charge on Avogadro's number of electrons. So what is charge on 1 electron? This F divided by N. So answer is B. Then 16th, during the electrolysis of a solution of silver nitrate, 9650 coulombs of charge was passed through the solution. The mass of silver deposited at cathode will be. Those who were present yesterday, Vishal, can you answer this question? 16th question. Can you answer the 16th question, Vishal?
Yes, ma'am.
Tell me. W is equal to atomic mass into I into T divided by valency into 96500. Now atomic mass of silver, Ag, is 108 and valency V is 1. Valency of silver is 1. So put the values and find the answer quickly. Vishal, you have to answer this.
Yes, ma'am.
Ma'am, 21.6
Huh?
is the answer. 21.6, ma'am. Ma'am,
No,
Miss,
I will
the
not say. Let Vishal answer.
10.8, miss.
Answer is 10.8. Vishal, did you get 10.8? See, what is the mass of silver deposited? So it is 108 into what is the charge? I into T, that is equal to 96500. Valency is 1.
Yes,
1 into 96500. So it is 108 by 10, that is equal to 10.8.
10.8, ma'am.
Yeah. The relation between Gibbs free energy and EMF of the cell.
Ma'am, doubt, ma'am. Ma'am, time, what is the time, ma'am? T.
See, I into T is equal to what? Q. And value of Q is
Oh, okay,
given.
ma'am. Ma'am, so if it was given in ampere, then definitely time will
Then,
be given
yes,
separately.
then time will be also given.
Ah, okay, ma'am.
Then you
Okay.
can't do without time. Right.
Yes, ma'am.
Now, Vaishnavi, do you remember this relation between Gibbs free energy and EMF of the cell? Do you remember this? Delta G is equal to minus N into F into E. I will not put this. Okay. So the answer is B. Minus N into F into E. So the answer is B. All of you are understanding? Now the 19th question. All of you think of the answer. Take 2 minutes and think of the answer of the 19th question. Magnesium displaces hydrogen from dilute sulfuric acid because oxidation potential of magnesium is less than that of hydrogen. Okay. Oxidation potential of magnesium is less than that of, the reduction potential of magnesium is less than that of hydrogen. Then both magnesium and hydrogen have same reduction potential and both have same oxidation potential. So C and D anyway cannot be. Now you have to choose between A and B.
A, ma'am.
B, answer is B. The reduction potential of magnesium is less than that of hydrogen. So if I write them all in the increasing order, magnesium comes above hydrogen. So hydrogen is below magnesium, and that is why reduction potential of magnesium, you can say, is less than that of hydrogen. Now we have done many questions of the same type. Now you should all be able to answer these questions. This is similar questions we have done. This is just one more to see whether you have been paying attention in the class. Now, this is for Madhavan. You were present yesterday. Madhavan, tell me.
Yes,
If
ma'am.
96500 coulomb of electricity is passed through copper sulfate solution, it will liberate how much of copper sulfate? See, copper sulfate is, it will liberate how much of copper? So copper is 63.5 and the atomic mass of copper is 63.5. So you have 96500 coulombs of electricity. How much copper will be precipitated?
100.
How will you find? You can
Ma'am,
either
the
use a
answer
formula or
31
without
point.
using. Tell me.
The answer is 3.17.
I can't hear you, Madhavan. Can you say it again?
Ma'am, Sanjay was saying it.
Sanjay. Sanjay.
Ma'am, is the answer 31.76.
31.76. Now, Sanjay, you are answering all the questions. Please give time to the others also to answer. So there are two ways of doing it. One way of doing it is that 2 Faraday, right? What is 2 Faraday equal to? 2 Faraday is equal to 2 into 96500. So you can say 2 into 96500 coulombs. It discharges how much? Molar mass of copper, which is 63.5 grams, right? So 96500 coulombs will discharge how much? 63.5 divided by 2, that is 31.76. Okay, did you understand? So you can write it like that. The other way of doing it is you take W, right? W is equal to 63.5 into how much coulomb has been passed? 96500. I into T is that. Into valency into 96500. So this and this get cancelled. Again, you get 63.5 by 2. So it is 31.7. Right? So that is the answer. Now, fused NaCl on electrolysis. Now, nobody else will answer this question. This will be answered only by Vishal. Tell me. Fused NaCl on electrolysis gives dash on cathode. Even if you are wrong, doesn't matter. Tell me. I am doing electrolysis of sodium chloride. What will come on the cathode? The hint that I can give you is that cathode in a electrolytic cell, cathode is negative and anode is positive. Okay, you can remember with the word panic. Positive anode and negative is cathode. Okay, so which ions will get deposited at the cathode? First of all, which ions will move towards the cathode? Vishal,
Yes, ma'am.
tell me, which are the ions which will move towards the cathode? Can you see NaCl molten? It will give which ions? Na plus and Cl minus, right? So this is what positively charged ion, right? What is the positively charged ion? Sodium. And what is the cathode? Negative. So where will sodium
Negative.
go? To the cathode. Did you understand? It will be attracted
ma'am.
towards the cathode. So what will be deposited at the cathode? Sodium,
Sodium.
right? Because there are only sodium and chloride ions. The positively charged ions will get deposited at the cathode. And what will get deposited at the anode? Chlorine. Okay. So that is how you have to learn. Now, molar conductance of 0.15 molar solution of KCl is given if its conductivity is if its conductivity is molar conductivity of one is given. So what is the molar conductivity? You have to find molar conductivity of 0.15 molar solution if its conductivity is this much. So this is easy. Lambda m is equal to kappa into 1000 divided by molarity, right? So what is kappa? 0.152 into
Ma'am, it's answer
1000.
124.
Is it option C, ma'am?
Answer is, tell me what should be the answer. I didn't
Option C,
calculate.
ma'am.
It should be option C, 0.15. So it should be approximately this much. Good, very good. Now, how long will it take to deposit 50 grams of aluminium from an electrolytic cell containing Al2O3 using the current of 105 amperes? Now you can do this because this time current is given in an ampere. So you have to find what? You have to find time. And you have to find time in what? You have to
Ma'am.
find time in hours.
Ma'am,
Yeah,
ma'am, per second, can you go for the next slide?
previous slide.
Yes, ma'am. Yes, ma'am. Thank you.
How long will it take to deposit 50 grams of aluminium from electrolytic cell containing Al2O3 using current of 105 amperes?
Ma'am,
How
is
will
the
you
answer
do this?
1.42?
I have not calculated this answer. Please calculate.
Miss, what is the molar mass of aluminium?
Aluminium is 27. So
I guess it's
W,
1.4.
W is equal to atomic mass or molar mass into I into T divided by valency into 96500. So what will W is given 50. So you can, how will you write this? 50 is equal to 27 into I is 105 into T divided by 3 into 96500. So what is T equal to? You will get T in seconds. So what will you get? Please, I didn't calculate this one and keep. So T will be equal to 2 into 96500 equal to divided by 27. Okay, about 5,000 something you get the answer. You divide it by, you have to get it in hours. This is in seconds. So you again divide the answer with 3600. So 1.42 hours. Somebody already gave that answer. Very good. Sanjay, you gave the answer.
Yes, ma'am.
So you are becoming perfect in this. You. Amount of electricity required to deposit 1 mole of aluminium from a solution of AlCl3 will be 1 mole of aluminium. This is easy. Madhavan,
Ma'am,
can
it's
you
option C.
answer?
Ma'am.
Answer is C. Very good. Option C. Hari Raghav, what happened? Your internet
Ma'am, yes, ma'am.
this
Yes, ma'am.
week?
Little bit
Okay.
low.
If limiting conductivity of calcium and chloride ions is given there, then value of limiting molar conductance will be how much of calcium chloride, right? So limiting molar conductance, you can write this M. Limiting means molar conductance at infinite dilution of calcium chloride will be equal to what? Limiting this of calcium 2 plus 2 into limiting conductance of chloride minus, because it
Ma'am, is
is
the answer
CaCl.
43.3?
It could be. I have not calculated, and 43.3 doesn't look like, because it should be larger. So calcium is
You should option B, ma'am. B.
119 plus 76.3 into 2. So 76.3 into 2 is equal to plus 119. Yes, answer is B, 271.6. Did you understand how we did this? If you know the molar conductance, then you can always, of each of the ions, you can find the molar conductance of the salt. Okay. Now this is match the following. Now all of you just spend a few minutes and tell me the answers. Okay. Now all of you are there. Some people have not answered. I'm very happy that everybody is present today. Sanjay, I don't want you to answer. Vaishnavi. Hari, what is it? Hari Raghav, no. Hari Haran, you answer now. You have not said anything for a long time. Tell me, Hari Haran, what is first one? How do I connect? E cell is easy. What is the unit for E cell, Hari Haran? This G, you know, it is same. No, G is what? Anyway, if you know 3, you will know 4 also. I think G is for cell constant. This is cell constant. Right? So, who will tell me? Hari?
Ma'am.
Ma'am.
Hari Haran, are you telling me the answer? Are you there, Hari Haran?
Can you hear me, ma'am?
Please switch on while you are answering. At least that time you can open your, switch on your camera for a few seconds. Hello? Hari Haran, are you there? Please answer. Hari Haran is not answering only. Vaishnavi, you answer now. Tell me, all these things you have learned, you were there in that class. Or you have not attended any class. Vaishnavi, did you attend any class on electrochemistry? I don't think you have. Have you? Vaishnavi? Are you there, Vaishnavi? Oh, everybody is. All of you have switched, joined and you have disappeared. This is very bad. Vaishnavi, are you there? Vaishnavi? Oh, interesting.
Ma'am.
Yes. Hari Raghav, are you there?
Ma'am, yes, ma'am.
Yes, tell me the answer.
Ma'am, for E cell it's D, ma'am, volts.
This is D, very good. Then kappa should be what? Is this one? And this
Is it not C, ma'am?
No, this C is cell constant, this one.
Okay.
Okay. Then those who are, this is for Sai Kalyan. Sai Kalyan, you can tell me this because you will remember this easily because you have made a presentation you said in the school. Sai Kalyan, tell me, please. I can't hear you. Please, can you switch on your camera for a minute?
Miss, none of this came in my presentation.
Okay, none of this was there, but I have taught you. Based on that, you can tell.
Ma'am, for third one, can it be D?
Only Sai Kalyan. Sai Kalyan will answer. Tell me. Sai Kalyan?
Miss, for fourth one, in the column 2, will it be C, miss?
Fourth one is B. Does not involve any ion and can be used in hearing aid. Okay, very good. Then Leclanche cell.
Miss, Leclerc is the option E, Miss.
Converts energy of combustion into electrical energy. It is actually Leclanche cell has zinc at the anode. Okay, that is the Leclanche cell. The round cell, that is Leclanche cell. And then nickel cadmium, can you tell me? That is the last thing I told you yesterday. It is also a rechargeable cell. Just like lead accumulator, nickel cadmium is a rechargeable cell. And fuel cell, you know, tell me.
E, Miss.
Converts energy of combustion into electrical energy, or the cell reaction is this A is also correct. Cell reaction of fuel cell, you get only water. That is the interesting thing about fuel cell. So it can continue for a long time. As long as there is hydrogen and oxygen present, it will continue to work. And the byproduct is water, which is not, which is also very useful, especially in your space programs. Now this one. Now this is a little tricky. All of you should look at it carefully and then answer. Otherwise, probably I should go to the other questions. This I will give you as homework, but how will I give you? Okay, let us do it now. Match the items of column 1 to column 2 on the basis of data given below. Okay, now fluorine. Now, fluorine is, what should it be? It is a difficult one. First one. See, one thing that you should understand here is very easy. One is that fluorine is a non-metal. So in all these options, this C is a non-metal. So it could be bromine or it could be fluorine. Lithium and silver are, as lithium and gold are metals, right? So answer has to be C, but it is, which is best oxidizing agent. You know, fluorine is the most electronegative element. It is the best oxidizing agent. Why is it the best oxidizing agent? Because its reduction potential is the highest. Okay, where is the reduction potential? 2.87. So if the reduction potential is the highest, it has to be the best oxidizing agent. Okay, because it will get reduced easily, and so it is a good oxidizing agent. Now look at lithium. Now lithium metal is the strongest reducing agent. So which will be the strongest reducing agent, which has the lowest reduction potential? So which is the lowest reduction potential? Lithium. So lithium is the metal with strongest reducing agent. Are you able to understand, all of you? These are very important things which you should, concepts which you should be very clear in your mind. Then Au3 plus. Okay, so Au3 plus is, it should be an unreactive metal, I think. Maybe let us leave it for the time being. It also has a reduction potential, which is positive. So it is a metal ion, which is an oxidizing agent here, because it has a positive reduction potential, which is high. So it is a metal ion, which is an oxidizing agent. Okay, so metal ion, which is an oxidizing agent, like this. Okay, then Br minus, anion, which is the weakest reducing agent. It is a which will be the weak reducing agent. The weak reducing agent is the one which has a very high value of reduction potential. So it will not reduction potential. So it is Br should be a weak. What should Br be? Non-metal, unreactive, anion, which is the weakest reducing agent. So it has a high reduction potential. So it cannot be a reducing agent. It can be only a oxidizing agent. If it is a good oxidizing agent, it has to be a weak reducing agent. So anion, which is
Miss, Br minus as Br minus only known should be G option because it has higher inert
metal
value.
ion, which is Br minus cannot be G because Br is actually, it's written as metal ion. This is an anion. That is a difference.
Okay.
So I can't connect it to G. But let us leave this one and then we'll do that later. Au is an unreactive metal, that we know. It is not very reactive. Silver, gold and platinum, these are two metals which are not very reactive. Then Li plus metal ion, which is a weak oxidizing agent, right? Li plus is a metal ion. It is a strong reducing agent and a weak oxidizing agent. F minus is an anion that can be oxidized by Au3 plus. Oxidized. If it can be oxidized means it must gain. So seventh one can be F, anion, which is the weakest reducing agent. Fifth one, anion, which is the weakest reducing agent, right? Because it is the strongest oxidizing agent, right? It is the strongest oxidizing agent because it has the highest reduction potential. So it should be the weakest reducing agent. So which one remains now? Anion that can be oxidized by Au3 plus. Can it be? Reduction potential. It has to be this only then. 4 has to be this. Okay, so this is how you can match the following. So you have to hear what you have to remember very clearly. If SRP is high, these are the things you have to remember. Let me write these important things. I can't shift this here now. So if SRP is high, SRP means reduction potential is high, right? That means it can be, the species can be reduced easily. If it can be reduced easily, what is it? It is a strong oxidizing agent, right? And if SRP is low, then it can be oxidized easily. And if it can be oxidized easily, it is a strong reducing agent. So these are things you should remember very clearly, then you will be able to answer these questions. Okay. Now we have questions which are numericals. So till now we were doing MCQs. Now I have collected a few numericals for you. That day we did only one each of each type. So we'll practice a few numericals. So now tell me.
Ma'am, can you show the before slide, ma'am?
Previous slide, yes. Vaishnavi, are you back? Are you there? Vaishnavi? Hello? Hariharan, are you there?
Yes, ma'am.
Hariharan? Hariharan, are you
Can you
there?
hear me, ma'am?
Yes, I can hear you. Hari Raghav, are you there?
Ma'am,
Hari
yes, ma'am.
Raghav. Kalpagesh Madhavan, are you there?
Yes, ma'am, I'm
Madhavan,
there.
are you?
Yes, ma'am. Yes, ma'am.
Sai Kalyan is there. Vaishnavi, I don't know what happened to her. And then Vishal, are you there?
Yes, ma'am.
Vishal, yeah. See, children, if you are not switching on your cameras, it is very, very difficult for me to teach. So, you know what I'll do is next time I am going to put a condition that, like physics, you have to come to the tuition center and then attend the class, because then I can see the whole class and you can see the screen. Otherwise, there's no point in my continuing to teach. I'm going to tell your, coordinator that it is not possible. I'm politely requesting all of you. If you have a problem, I understand. But if you don't have a problem, then please. So at least I know you are around. How will I know that you are around? I can't keep wasting time in asking, are you there? Are you there? Are you there? At least when I take your name and ask you to answer a question, you should respond. Okay, now let us do this question. Current of 10 amperes is passed for 80 minutes and 27 seconds through a cell containing dilute sulfuric acid, right? How many moles of oxygen will be liberated at anode? How many moles of oxygen gas will be liberated at anode? So what is the question? You have to not find mass, but moles. But the formula that we have, what do we find? We find the mass. So we have to find W is equal to atomic mass into I into T divided by valency into 96500. I hope you have understood this. Okay. Now atomic mass of oxygen, all of you know. For oxygen, it is how much? 16. So 16 into I is given 10 amperes into current past 80 minutes and 27 seconds. So how will you convert 80 minutes and 27 seconds into seconds only? How will you do that? It will be 80 into 60, right? Plus 27. Right? Convert minutes also to seconds. And divided by valency is 2 into 96500. Okay. So what will you get? This and this cancel. You will get 8. This and this cancel. So you will get 8 into this is 4827 divided by 9650. So if I do that, the answer that I get is 4.00 grams. But what do I need to find? The number of moles of oxygen gas. So how will I find number of moles? Number of moles of oxygen gas will be equal to mass divided by molar mass. Right? What is the mass of oxygen? 4.00. And what is the molar mass of oxygen gas? It is 32. 16 plus 16 because it is O2. So what will that be equal to? 0.125. I think this is 1 by 4, 1 by 8. So it will be 0.125. 0.125 moles. Vaishnavi and Sanjay, they left. Okay. Now, how will you do the second part of the question? Calculate the amount of zinc deposited at cathode when another cell containing zinc sulfate is connected in series. Okay, so what is the formula that we use? W1 by W2 is equal to E1 by E2. Right? So what is W1 of oxygen? 4. By W2, we have to find out of zinc. And E1 of oxygen. E1 of oxygen is atomic mass by valency, that is 8, divided by equivalent mass of zinc. Equivalent mass of zinc is 65 divided by 2, that is 32.5. So if you do this, you will get the value of W2. W2 is how much? It will come to 16.25 grams. Okay, so this is how you can do this question. Now I'll skip the next one because that is easy, you can do it. This one also I'll skip because all of you can answer these questions. 1 mole of Al3 plus iron to aluminium. How many Faradays will you need? Right here, how much charge is required? 3 Faraday. 1 mole of Cu2 plus 2Cu, 2 Faraday. And 1
No,
mole
last one
of,
is 1, no, ma'am.
which one?
Oh, last one is, what is the answer, ma'am? Third one.
So the last one, MnO4 minus 2 Mn2 plus. Right? You will have to find the oxidation number and change in oxidation number. How many electrons are required to convert MnO4 minus to Mn2 plus? Now, what is the charge on MnO4 minus? Mn on in MnO4 minus. So MnO4 minus. What is the charge on manganese? X plus minus 2 into 4 is equal to minus 4. MnO4. I'm sorry, this is a mistake. MnO4 1 minus. Right? It is, let me write it, MnO4 1 minus to Mn2 plus. Right? So first find the charge on manganese. So it is charge on manganese is MnO4 minus is equal to, how will I find X minus 2 into minus 2 is equal to minus 8 is equal to minus 1. So X is equal to plus 7. Right? So here the what is the oxidation state? Plus 7. And here it is changing into plus 2. So how many moles of electrons have I used to convert 7 to 2? 5 moles. Right? So it will be 5 Faraday. Did you understand? So if you are given an ion, this is how you have to do it. Convert and see how many electrons are required to change that oxidation state from one to the other. Now there is, can you see the whole screen? My screen partly has become white for some reason. Can you see the whole screen, all of you? Can you see a part of the
Yes, ma'am.
screen white? I will do it like this. Now you can do it. Just one. Sai Kalyan, can you see the full question now?
Yes, miss, I can see the question. Can you move to the last slide for 1 minute?
Okay.
The before slide.
This one
Before.
or before
Before
this?
14.
Yeah, this one.
Okay.
Now this question also I am skipping because all of you can do it. It is all the similar type of question. We will just do this one here for the sake of revision. Predict the products of electrolysis in each of the following. What is the product of electrolysis in each? So you have taken aqueous silver nitrate solution. So the first one is you have taken aqueous silver nitrate solution. So aqueous AgNO3. So aqueous silver nitrate solution will give me what? It will first give me, it will contain water and it will ionize into Ag plus NO3 minus. And there will also be water. So what did I tell you? And here, what is deposited at the electrode depends on the position of the element in the electrochemical series and on the nature of the electrode. Now, if the electrode is silver electrode, then cathode reaction is very easy. Cathode silver has a high reduction potential. So at cathode silver will get Ag plus E minus will give you Ag. So at cathode you will get silver. Silver will get reduced. Why? Because the reduction potential of silver is higher than the reduction potential of water. So hydrogen will not be formed, silver will. And then at anode, what will happen? Since it is a silver electrode, again, the reduction potential of, at anode, what will happen? Oxidation has to take place. And for oxidation, whichever has a higher oxidation potential should get oxidized. So here, this is silver electrode. So the oxidation of silver will take place. So here Ag will, oxidation means it will lose electrons and give Ag plus E minus. So this is at cathode and this is at anode, especially why? Because there are silver electrodes. If the electrodes were those electrodes which are inert, then at anode I would have got oxygen, otherwise I get silver. Then aqueous solution of silver nitrate with platinum electrodes. So again, it is the same thing, but it is platinum electrodes which are not reactive. So at cathode, I will get silver like here, same. And at anode, I will get oxygen because water will start getting oxidized at anode. Okay, so water will give you oxygen. Then dilute a solution of H2SO4 with platinum electrodes. So this is 1. This one is 2. The third one at anode, first at cathode, let me write cathode. So at cathode, it is H2SO4. So you can imagine at cathode, you will get only hydrogen. And at anode, you will get oxygen. Okay, water will be the one which will get oxidized there. Aqueous solution of copper chloride with platinum electrodes. So when I take aqueous solution of copper chloride at cathode, I will get copper. And at anode, I will get chlorine. Okay, so you have to, they will give you either the values of the electrode potentials will be given to you, or you have to just remember in case of aqueous solution, mostly you will get whatever the anion is, you will get that, or oxygen you will get. Okay, so that is how you find out what is formed at cathode and anode. Now this question, next one. Okay. So now they were asking to use table 3.1. So I have just used, I've kept the values here, and using these values, you have to find out which reaction is feasible and which reaction is not feasible. So we'll do each reaction one by one, Fe3 plus and I minus. So if it is Fe3 plus I minus, right? So Fe3 plus would be changing. This is a higher oxidation state, so it would be changing to Fe2 plus. So this is getting reduced. So I2 should be getting oxidized I2. Right? So what is iron is getting reduced. Okay. And iodine is getting what? Oxidized. Right? So what will be E cathode minus E anode? All the values of reduction potential are given. So for the first one, E0 cell will be equal to E cathode minus E anode. What is the cathode? Cathode is where oxidation takes place. So what is getting oxidized? Iodine. So what is the thing of iodine? It is plus 0.54. And what is it for iron? Iron is,
Miss, anode is the place where the oxidation will take place on this.
I am making a mistake. Yes, you are right. So this one should be the cathode. Anode is where oxidation takes place. So this should be 0.77 minus 0.54, right? So what will you get? 0.77 minus 0.54. You will get 0.23. 0.23. So since the answer is coming positive, what will I write here? This cell, this one is feasible, right? This is feasible. Now you look at Ag aqueous and Cu solid. So what will I write? Cu plus Ag plus. What will it give? Obviously, Ag will change into Ag and Cu will change into Cu2 plus. So what is happening? Copper is getting oxidized and silver is getting reduced. So how will I write E cell? E cathode. Cathode is what? Where reduction is taking place. So silver I will write first. Where is silver? 0.80 minus anode. Anode is where oxidation is taking place. So that is copper. So minus 0.34. So that should come to 0.46. This is also positive. So this is also feasible. Now let us look at the next one. Fe3 plus. So let us write here Fe3 plus Br minus will give you Fe2 plus Br2. So this is getting reduced and this one is getting oxidized. So E cathode, this is getting reduced. So E cell, E cathode is iron 0.77 minus bromine 1.09, right? So answer will be negative, something negative. So since this is negative, this is not feasible. Wherever the answer is negative, it is not feasible. Now look at Ag plus and Fe3 plus. So Ag solid plus Fe3 plus would be changing into Ag plus Fe2 plus, right? So this is getting oxidized and this is getting reduced, right? So what should be the E cell? E cell will be equal to E cathode. What is cathode? Where reduction is taking place. So that is 0.77 minus, this is Oxidation, that is minus 0.80. So this will be minus 0.03. So that will be also not feasible. In the same way, you can find out about the last one also. Okay, I will not tell you how to do it. Please do it, somebody, and tell me the answer. Is the last one feasible or not feasible? Sai Kalyan, can you tell me?
I will do and tell this.
Please do it.
Miss, it is
All-
Fe2 plus and Fe3 plus, miss.
Fe2 plus.
Okay.
So it will be Fe2 plus Br minus. What will it change into? This will get oxidized. Fe3 plus Br minus will change into Br2. Br2 aqueous. Okay, Br2 is aqueous. I'm sorry. So that will change into Br minus. Okay, so the reaction will be, I will have to take another page. So it will be Fe2 plus Br2 will give Fe3 plus 2Br minus. Right, so this is getting oxidized and this is getting reduced. So Br you have to write first. So what is the for Br? 1.9. So E cell will be equal to 1.09 minus anode 0.77 minus E cathode. What is cathode? Cathode is where reduction is taking place. Oh, I wrote again. So this is reduction and this is oxidation. So E cathode minus E anode. So minus 0.77. Okay, so this also should be positive answer. And so this is also feasible. The last cell is also feasible. Okay. Now this question, similar questions we have done, so I don't think we have to do this. Now this one, let us try one or two of them, then I will stop. Only 4 minutes are remaining. So you have to write the Nernst equation and EMF of the cell for the following cells. So the first one, I will just show the first one. The equation is already given to you. Now this is cell notation, which will, what does it tell you? The left side is the anode and the right side is the cathode. It also tells you that the concentration, it's not a standard cell because concentration of the electrolyte is not 1 m. So how will you write Mg? What will be E cell? E cell will be equal to, you have to just write the Nernst equation. You don't have to solve it. So what will it be? E0 cell minus 0.059 divided by N. How many electrons are getting exchanged from here to here? 2. So by 2 log of product by reactant. Okay, so what is the product in this reaction? What is the product? You should write the cell reaction here. So Mg gives Mg2 plus 2E minus, and Cu2 plus 2E minus gives you Cu. So this and this get cancelled. So Mg plus Cu2 plus gives Mg2 plus Cu. So you know what is the reactant and what is the product. So what is the product? Mg2 plus. So concentration of Mg2 plus, you will write 0.001 divided by concentration of the reactant 0.0001. So this is the Nernst equation for the first one. And similarly, you will have to learn to write the Nernst equation for all others. So once you write them, you will get confidence. This is a question from your question paper, from your textbook. So I would suggest there are not too many questions. You should learn to do all the questions from the textbook. Try out all the questions from the textbook. All right. How many are there? 7 are there now. Who came back? Vaishnavi, you came back? Vaishnavi,
Ma'am, can
what
you
happened to you, Vaishnavi, in between?
Ma'am, power went off in my area. So
Huh?
I was trying.
I-
Ma'am, can you hear me? Ma'am,
I can't hear you at all. Okay, all of you, please try to solve all the questions from the textbook. Then only you'll be able to do the test well.
ma'am, can you hear me now?
I can hear you now. Vaishnavi, I was very disappointed. I was calling your name. You were not there. What happened to you?
Ma'am, due to network issues, I left the meeting, ma'am. I couldn't join back for half an hour.
Okay.
I was trying.
Okay. Right. So if the learning room is not very far from where you stay, it is better you attend the class from the learning room, because such issues,
Ma'am, but
you know.
due to the timings, it's not convenient, ma'am.
Okay, due to the timings. So is the internet connection, all of you say you have difficulty in internet. What I suggest is you should all have an internet connectivity. You should sit where your Wi-Fi is. Sit close to the Wi-Fi. If you go and sit in another room, no, and close the door, you will not get connectivity. So it is better you should sit very close to where your internet connection. Okay, so I will stop share now. So thank you very much, all of you. At least today you are all present. My camera, I don't know how to switch it on. My half of it is. So thank you very much for attending. Now electrochemistry is over. So I want to ask all of you, what is the next topic you want me to take? Option is I take D block elements, or I take aldehydes and ketones, or I take kinetics. So which one do you want to start?
Aldehydes, ma'am.
Aldehydes. Okay. Anybody else? Do all of you want aldehydes? Huh?
Ma'am, aldehydes, ma'am.
Acha, most of you want aldehydes. Sai Kalyan wants kinetics, right? Kinetics is a short topic. We will take kinetics also. We have done back-to-back 2 physical chemistry topics. So we can do kinetic. We can start with aldehydes, ketones in the next class, next week. Okay. So thank you, all of you. Today, all of you were present. I'm so happy. I really wish that your internet connectivity is better next time and we are able to see each other. My camera is also gone and some problem in this. Okay, so I'll also take care so that next time there is no problem. Okay, then see you all. Bye.
Thank you, ma'am.
Thank you, ma'am. Bye, ma'am.
Thank you, ma'am.
You're
Thank you,
welcome. You're welcome.